Typically, the wall assembly on these high-rise buildings, from what I've seen, and I'm not an expert in high-rise, but is a typical, it's a curtain wall, curtain wall facade gets hung off the outside of the slabs, right? That needs tweaks because there's some air sealing details that need to be addressed. How do you make continuity through the whole building with your air barrier? And I'm going to go into some details on each of these topics after this slide. The energy demand in your auxiliary spaces, can be quite high, like fitness centers, things like that, laundries. Size of apartments. There are some refrigerant limits that you have to watch. If you're using, say, a mini-split VRF system, the length of the lines and the amount of refrigerant in those lines actually is an issue that you have to watch with code. And then the ventilation requirements actually conflict with code. So I'm going to go into that as well. Windows, you need to, more than the U value for windows, because it's an envelope thing, and the U value is not as important as comfort. You have to evaluate what the temperature on the interior surface is from a comfort perspective for Passive House. This is what they consider a soft criteria. And you also have to look at the condensation potential. So if you need to use a metal frame, you have to have your analyst look at the condensation potential on that frame. And then, so Windows, the European rating versus the American rating, it's a ISO EN rating in Europe. Passive House wants those numbers. We need specific numbers from those rating systems. You can't take the NFRC numbers from the US and just convert them. There's no easy conversion. I have been fighting for 3 months on this project to just try and get the project team to understand any American window manufacturer that has not already produced these ratings is going to have to produce these ratings. That's what the Passive House certifiers want you to do. So this has caused some problems. There's definitely European windows available in the US, but if you have an American manufacturer that wants to bid your project, they're going to have to come up with these values. Big sticking point right now. And then ventilation. This is really the big sort of elephant in the room. How do we handle ventilation? Is the Passive House requirement appropriate for high-rise multifamily buildings? The requirement is, and let me tell you what it is, it's 0.3 air changes per hour, balanced ventilation at a minimum in each occupied space, okay? And then they want you to be able to give the occupant control to boost that up if they're in the kitchen, in the bathroom, if they're showering or they burn some toast or something like that. So they want you to be able to boost those flow rates up. What you're going to see is that flow rate, that 0.3, is lower than code. Okay, so we'll discuss how we've been dealing with that on some of our projects here. Let me see how we're doing. Okay, so let's talk about envelopes. So curtain wall facades. Basically, typically in the city especially, steel framing, right? That's typical. So there's a lot of thermal bridging there that has to be addressed. You can't just have a steel stud without any exterior continuous. It won't work. It's not even allowed in code. They're non-structural, so they're just hanging off the building. So you got to consider the weight of the windows. If you're building a curtain wall and you're having the windows installed in the factory, those windows are heavy. The triple pane windows are very heavy. So you need to consider that in the whole plan. We've been working with companies and asking for design assist packages from the curtain wall companies so that they can sit down with us and work through all the details, the air sealing, the window wall connections, all of that. So it's a really involved process when you come to the curtain walls. And then the good thing is they're designed to span multiple floors, which is really key because these slabs, where they're hung, right, if you don't have continuous insulation past each one of those slabs, you have a thermal bridge at every floor, and that wouldn't be allowed. Okay, so you have to make sure you have continuous insulation somehow, and so really the simplest way in a high-rise is to use a curtain wall facade to get rid of that issue, but it doesn't get rid of all of the issues. You know, the pros are the continuous insulation on the exterior of the building, and then the panels are constructed in the factory, so you have less variability in the field. There's a little bit more quality control until you get them on site. The cons are attachments to the building and other panels. So how do you make sure that that air seal is tight? And how do you work out the air barrier transitions in that building? The final air sealing is generally done from the exterior. Once the building is all complete, all the walls have been hung, then somebody strings down the building on the outside and caulks all those seams. So if you're trying to do a passive house project, what you should be doing along the way is having it commissioned as you go, having testing done on certain sections of your walls and certain components that are connecting so that you can be sure that your air sealing is being done properly. You never wait to the end of a passive house project to do your testing. If the air sealing is only done at the end, how do you do that? So you might wind up with 2 air barriers. Your consultant might insist on the air barrier being on the interior of this panel for the construction process so that we can test and make sure you're getting to the levels that you need to. And then when they do their final caulking at the end, it's just an added level of moisture and air control. So the sequencing is a bit odd with a curtain wall. And then in the city in particular, fire-rated insulation is definitely a must. So we've been dealing with mineral wool quite a bit. Any time we say, well, can we use this foam? No, you can't use that foam. No foam. Okay, no foam. So it makes the wall thicker because you can't get as much R value out of mineral wool as you can. So that's just one of the issues there.